Hi, in this video we're going to talk about moment. Moment has another name, it's called torque, and both of them, that means it's force acting at a distance. So what does that mean? Let's look at this example. Imagine you are trying to open the door and you put your force at the doorknob, and if you're looking at the down view, top view, so which means if this is a door and this is our doorknob, right? And here is our hinge, and you apply force to open the door, to rotate it, to make this door open, and have this swing motion of the door. And so that's a force acting at a distance because it's going to rotating along the hinge. So the moment, also called torque, has a formula. It's this M is equal to the force you apply down times the distance. However, this distance have another name. It's called a moment of arm. And moment of arm, it's a distance, so which means it's going to be in meter, right? But what's this moment of arm? Moment of arm is very particular. Have to be perpendicular distance. Cannot be anything else. Have to be perpendicular distance from the rotational point. For example, for the door, the rotational point will be the hinge, right? Where the point, this object is rotating about from the rotational point to the force. That's going to be the distance. It's also called the moment of arm. It's perpendicular distance from rotational point to the force. Now let's look at some example here. Imagine this is the line, and this is our C, that's our rotational point, and we have a force here at A that's gonna be applied at this direction. Okay, so this is our force and we're rotating about rotating about C. So what would be this perpendicular distance? I'm going to draw using red color to show that moment of arm. It's going to be from rotational point to the force. Rotational point to the force. And it cannot be any random distance. So that will not be right? Will have to be the perpendicular distance. That's going to be our moment of arm for that situation. Okay, now let's look at another example. It's example 1, example 2. Then this is a force F in that direction, and if this force is rotating about A, what will be the moment of arm? So that will be from rotational point to the force, and it have to be perpendicular. So if I were to draw perpendicular, it would have to be this, right? And so feel free to extend the force at the direction, at the line of action. So that's red part is going to be our moment of arm. Imagine this force is not rotating about A, it's rotating about B right here. So take a moment thinking about how would you draw the moment of arm. Okay, hopefully you already have an idea. It's from rotational point to the force and it have to be perpendicular. So that will be our moment of arm, D1 and D2 respectively. Now let's thinking about another situation. If we are rotating about C, what would be the moment of arm for that? And because this force directly going through this point, and so the moment of arm, if I were to draw from C to this force, C is already right on the force. So tell me, what do you think this moment of arm should be? Equal to 0. So yeah, in other words, if you go back to this equation, force times this distance, moment of arm, that's going to be equal to 0. There's no moment, no torque. So this situation is you are trying to open the door. Go back to this example. Your force here is right going through this point, the hinge. Try that. No matter how mighty you are, it's not going to open the door, right? Because the moment is equal to 0. Because this force directly going through this rotational point. The moment of arm is 0. There's no moment, no torque, and it cannot rotate this door. Okay, so those are some examples of the moment. Now let's look at a little bit more. So continue to go back to this example 2. And we have 3 examples. So here I'm going to introduce some convention. Notation we're going to use. Moment is going to use M. And I'm going to take care of the subscript and the superscript. The subscript is going to be where you're rotating about. For example, I'm choosing this point, rotating about A. And a superscript will always going to be the force. Okay, so we want to find this force rotating about A. And this will also say, this force, if I were trying to rotating about B, what would be the value? Then what would be this force rotating about C? What would be the value? I think we can already know, right? Using the formula for the moment is force times this moment of arm. Therefore, the force F times moment of arm rotating about A will take care of it. It's going to be this D1. And for F rotating about B will be force times moment of arm will be D2. And for force rotating about C, that will be 0. So you already know those 3 solutions. Now let's take a look. I want to introduce something very important. It's about this moment. Not only it's a vector. So in other words, not only have a magnitude, have a value, it also has a what? Direction. If we already figure out the magnitude part, right? And it's force times moment of arm. How about direction? So here is a sign convention. If make this counterclockwise rotation, that will be positive. If this rotation is clockwise, that will be negative. So now we're going to go back this set and to figure out our direction, because I only take care of the magnitude. I haven't taken out direction. Is it positive or negative? We haven't figured out yet. So let's thinking about it. So let's look at scenario number A, which means this force is rotating about A. So if I were isolate this out, A is here and force is here, right? So think about if this is going to be orbit around A, what rotation does that make? Is that clockwise rotation or counterclockwise rotation? So this is counterclockwise. So this is going to give us positive value. Okay, now let's thinking about scenario number 2. So this is A. Now let's think about B. So this force is here, and B is somewhere relative to the force down there. And this force is going to rotating about B, just like the force is the door. It's going to rotating around the door hinge. So make this trend. That's going to be this rotation, right? Orbit around. And that direction is clockwise. Since it's clockwise, it's going to be considered as negative. So that will be my correct answer with a negative in front of it. Have I not take this consideration, my answer would be wrong. Will have to be negative FD2 because it's a clockwise rotation. Okay. Now the last scenario, we know the force going through the rotation point and moment of arm is 0, so 0 doesn't matter, it's positive or negative, there's no rotation at all. So that is our moment introduction. So quick cap, we introduced the formula. we know the moment, also called torque, is define the rotation. And it's force acting at a distance. So it's force times a distance, and which is force times the moment of arm. This moment of arm is very particular. Has to be the perpendicular distance from rotational point to the force. And we look at some examples, and the key is how to find this moment of arm. Have to be, again, perpendicular from rotational point to the force. Right? So knowing that, and we also introduce this moment not only have magnitude, force times moment of arm, also has a direction. If to make it clockwise, it's going to be negative. Counterclockwise is positive. One last thing to wrap up, this moment is going to have a unit of Newton meter because it's force times distance. You might argue Newton times meter, force times distance is joule. I agree. But when we talk about moment and torque, we instead of saying as a joule, we just say it Newton meter. Okay, so hopefully you have fun with this video, and I'll see you at the next one with the application of the moment. Okay, bye now.